Hello, welcome everyone to MGD assignment number 2. This assignment is based on the book Refactoring by Martin Fowler. I adapted the assignment to use Swift and to use various features that are part of the Swift language. Now, before we start the refactoring work, we need to set up our programming environment. So let's go to our Xcode. So this is our code. I'm just gonna open up our code again. So let's go to our desktop and we just double click this. Okay, and this is our program here. Okay, so let's begin by initializing our source code control system. So at least we have a copy, and so whenever we make changes to our program, if we make any mistakes, we can always go back and rectify it or revert to an earlier version. Now, the sample program is very simple. It is a program to calculate and print the statement for a customer's charges at a video rental store. The program is told which movies a customer rented and for how long. It then calculates the charges, which depends on how long the movie is rented and for how long, and identifies the type of movie. There are 3 types of movies: regular, new release, and children's. In addition to calculating charges, the statement also computes frequent renter points, which vary depending on whether the movie is a new release. Now, the book, if we can look at the book here, this is the book Refactoring by Martin Fowler. The book is written in Java circa 1999, which is 18 years ago, and it uses integers to denote price codes, whereas Swift has the ability to specify enums to specify types. Okay, so here is our program. We have movie class, rental, and the customer class is the statement method. So how would this program be described? Martin Fowler says it's not very well designed and certainly not object oriented. For a simple program that does not really matter, there's nothing wrong with a quick and dirty simple program. Emphasis is on simple. But if this is a representative fragment of a more complex system, then there are some real problems with it. The long statement routine in customer class does far too much. Many of the things that it does really should be done by other classes. Even so, the program works. But is it just an aesthetic judgment, a dislike of ugly code? It is only until we want to change the system. The compiler doesn't care whether the code is ugly or clean, but when we change the system, there is a human involved, and humans do care. A poorly designed system is hard to change. Hard because it is hard to figure out where the changes are needed. If it is hard to figure out what to change, there is a strong chance that the programmer will make a mistake and introduce bugs. Now we have a change request where the users want the statement to be printed out in HTML. As you look at the code, you can see that it's impossible to reuse any of the behavior of the current statement method for an HTML statement. Your only recourse is to write a whole new method that duplicates much of the behavior of the statement. Of course, we can copy and paste to make the changes. We can just do this. What if we do this, and then we just, oh gosh, and then we just, what if we do this? Copy, and then we go and paste it out, and then we call this HTML statement, and then we just put our rental records where we can put the H1 here, and then after that the H1 over here, and this sort of thing. What if we do that? But what happens when the charging rules change? Now we have to change both the HTML statement and the statement method here. And the problem with copying and pasting is when you want to make a change later. If you're writing a program that doesn't expect you to change, then cut and paste is fine. But if your program is long-lived and likely to change, then cut and paste is a menace. And then comes the next rule change. Users want to add in more categories but haven't decided what changes to make. For example, there's regular, new release, children. And if you're just adding in, for example, a special on horror films, on action films, and you want to create a new category, for example, case.action, then you have to make another change over here as well. So if your program is long-lived and likely to change, then cut and paste is a menace. Okay. So when the user want any more categories and they haven't decided what to change, you will know that as a programmer, these rules always change every 6 months or so. And this way it's going to get hairy. We copy the changes to another method. We then have to make sure our changes are consistent. And as the rules grow in complexity, it's going to be harder to figure out where to make the changes and harder to make them without making a mistake. You may be tempted to make the fewest possible changes. After all, if it works fine, if it ain't broke, don't fix it. The program may not be broken, but it does hurt. It is making your life difficult because you find it hard to make the changes your users want. This is where refactoring comes in. Okay, so let's go back to our source control and we gotta revert back our changes and discard all the changes that we make. Doof. Okay, so there are no more changes here. Okay, let's go back to our source code here. So when we begin our work in refactoring, we need to have a solid set of unit tests for that section of code. Unit tests are essential because we as programmers are still human and are prone to make mistakes. Now I've already created the unit tests here. It's just two unit tests here. One is to test when there are no rentals, and the statement should just say put the customer name, and it will print out saying that the amount you owe is 0 and you earn 0 frequent renter points. And the second test will be where the user rents out one of each different type of movie. Of course, it would be better if we had more comprehensive unit tests, but that's all we can. It'll work fine for this example here. Now, the only tricky thing about Xcode is that your unit tests are not really part of the scheme. It's not by default part of the scheme. That's the only problem with console projects in Xcode. So we come over here to the top left corner to MGD assignment. We click Edit Scheme and go to Tests, and then we just add in our unit tests as part of our project. And let's just do a test. Now all we do to run our test is go and click on product test, or if you can remember the keyboard shortcut, which is Command U. So let's go and run our tests. Okay, build succeeded. And the test succeeds. So our program works according to our specifications. So let's look at how we can start our refactoring. Now, the obvious first target for our refactoring is in this very, very long statement here. And we can see that we can look at how we can remove this clump of code here by using the extract method refactoring. It is obvious here that this is a switch statement and it looks like something we can extract into its own method. And the reason for this that we chose this in our first project as our refactoring is that it appears to be a logical clump of code, and there are two local variables, which is rental, which is not modified, and this amount, which is modified. So rental can be set as a parameter, and this amount can be a return variable. So let's go and refactor this. So all you do is select this piece of code here. So come here, select this part of code, edit, copy, and we got to create a function here called amount4 func amount4. Okay, and come here, and it returns a double, and we gotta paste it here. Return this amount. Okay, now our compiler is going to do automatic compilation and says there's no rental, and the reason for that is because rental comes from this method, the statement method, and it's not passed in. So let's create this and put this over here. and our compilation error should be gone. Okay, so that's good. After that, what we do is that we can come here and we can comment it out, and we got to just say that this amount is equals to amount for rental. Okay, and now we got to do a test. Test succeeded. Alright, so both the tests succeed. So this refactoring works, and because this refactoring works, we can just delete this amount of code here. So we move all this over there. So once this refactoring works, we can use our source control to commit. Okay, so we use move method to create amount for method to calculate amount charged for a rental, and we can commit all this. Okay, so that is our first step 1, which is to extract method to convert the switch statement into a method. Step 2. Now, the other thing about this method, if you look at it here, is that in this method called amount for, is this variable called this amount. It's the thing about the name this amount is that it's not very clear what this amount is supposed to be. It is actually the return value that got to be returning in our method. So the next refactoring is a very simple refactoring, is by renaming the variable. So we can just come here and we can click here and then click edit all in scope. Okay, or we can click an editor and click edit all in scope, and you can rename this variable called result into result. So it's clearer that when we are using this variable, it is going to be the return result of our function. Is renaming worth effort? Absolutely. Good code should communicate what it is doing clearly, and variable names are key to clear code. Never be afraid to change the name of things to improve clarity. With good find and replace tools, it's usually not difficult. Now, that was spoken by Martin Fowler 17 years ago. Now you can see that in IDEs, these functions, this ability to rename variables are built in. Okay. So any fool can write code that a computer can understand. Good programmers write code that humans can understand. Okay, so this is thing. So we got to do another commit here. So we got to commit this to, you can see our changes here in our source code control system. These are all the changes that we've done. So we got to put this as our rename our variables. Okay, so and we just got to commit our code, and we're done. Okay, so let's look at our next refactoring. Okay, step 3. Okay, we can see that as we look at amount for, it uses information from rental, but does not use information from the customer. Okay, and because of that, now a method should be on the object whose data it uses. So we should move it from customer to rental. Okay, so let's look at our code here. Notice this is our code. It only uses information from rental. It does not use any information from the customer. So we should move this into our rental code. So we got to use the move method statement. Okay, we got to first copy the code over to rental and just need to fit in its new home and compile. Okay, so let's copy this code here. Edit, copy, come over here, and we gotta paste it. Okay, there's gotta be a problem here because, okay, and since it is part of the rental object, okay, we don't need to have this as a parameter. Okay, and we can just put this here. So this movie is this movie, so we can just remove this. Okay, and to make sure, let's make sure that this thing works. Okay, we can actually do this. Return. Okay, return rental dot amount for. Okay, and we gotta do a test. Okay, so it works. So this thing works, and what we can do next is that we can actually replace this call of method. Okay, and we gotta call this mount here. Okay, so let's just comment this out, and we gotta look for our compilation errors. Okay, so you gotta say user mount for. Okay, so this one doesn't work, so we gotta put here. So gotta call this rental dot amount for, and we gotta test one more time. Okay, so build succeeded and the test succeeded. Okay, I made a small little change. I left the name for this as amount for. I'm gonna rename it as get charge instead. So let's call this get charge. Okay, and call this get charge. Okay. And we gotta test one more time. Build succeed. Test succeeded. So let's just remove this function here. Ta-da! And this test just for luck. Make sure you didn't do anything wrong. Test succeeded. Okay, so we're done. So let's just commit one more time. Okay. Use move method to move amount for from customer to rental. Okay, so that is step 3. Step 4. Now the step 4 is to eliminate this amount. Now the reason is because this amount is set to rental.getCharge and it's never changed. Okay, and a temporary variables cause a lot of parameters to be passed around unnecessarily, and you can easily lose track of what temp variables are for, especially long method. Yes, there is a performance to price to pay as it is calculated twice, but it's more effective to optimize later when the code is refactored. So let's look at it. Okay, notice this is this amount, right? Okay, and it's just assigned, right, and returned. So instead of using this variable, we can just put it into this, replace get charge here. Okay, so we got to put it over here. Okay, so what we gotta do is gotta copy this one, copy, and we got. Okay, so what we can do is this: we can just eliminate this variable. Okay, so we can use our compilation errors to tell us where is our problem. Paste it here. We don't need this assignment. Okay, and we got to test one more time. Build succeed, test succeeded. So this thing works fine. So we can remove this temporary variable. So we are done. So let's commit one more time. replace temp with use replace temp with query to replace this amount with rental dot get charge. Okay, you can see our changes here. So removed all this, and we just change this amount here. So copy it, commit the file, and we're done for this step here. So that's step 4, replace temp with query. Next thing is to do is that we can do the same thing for frequent renter points. So you can see that we have frequent renter points here, and then what it does is that it just increases this to gives 1 point. And if the movie is a new release, and if it's rented for more than 1 day, we'll just give him a bonus of another point, which means he gets 2 points. So this could also be extracted into a method in our rental as getFrequentRenterPoints. So it seems reasonable to put responsibility of calculation of points to rental, okay? Okay, since it's a judgment call, because it also depends on the number of days that we rented the film, the movie, but it seems reasonable enough. And rental is used in our calculation, so it can be passed in as a parameter. Frequent renter points modified but not read, so it can be assigned. Okay, so here we got frequent renter. Okay, so here we just give it, and then it's actually printed over here. So let's just create another function. Func get frequent. Oh, by the way, did we do a commit, by the way? Yes, we did. So we don't have to commit. Get frequent renter points. Okay, so it returns an integer. Okay, so we can just copy this over here. Copy this. Okay. So we could do this way, and you can just say return frequent renter points, and we could just say rental. Okay, so this works. The problem is this over here is 0 and 1. Okay, so but if you look at the code, actually it returns either 1 or 2. So actually what you can do is just replace this one here, and you can just replace this one. You can just say return 2, and this one returns 1, and that's it. Okay, and then this is our frequent renter point. So if we comment it out, okay, and we come over here, hold on, and yes, we actually need this variable. So what we can do is this: we can replace this with frequent renter points plus equals to rental okay dot get frequent renter points rental. Okay, and let's do a test. Build succeed, test succeeded, so our refactoring is successful. So let's just delete all this from here, and our code now looks like this. Okay, so let's test one more time to make sure that our code works. Make sure it didn't delete anything by accident. Test succeeded. Okay, so let's just commit. Okay, so we can just say that we extract method here. Use extract method to create get frequent renter points in rental class. So commit. Okay. So if you notice in our assignment here that we're using really small steps when we're doing refactoring, okay, and the key takeaway is this, that small steps are the best. That way less tends to go wrong. We make a change, we know what we're doing, we run our tests, it works, and then we commit. Okay, so let's look at our next refactoring. Okay, now as was suggested just in our one of our refactorings where we got rid of this amount, okay, as a variable. Okay, temporary variables can be a problem, and the reason is because they are useful only within their own routines. Thus, they encourage long and complex routines. And we have two temporary variables here called total amount and frequent renter points. And the thing is, they are only useful within their own function. Okay, and we can actually refactor this into a query using the replace temp with query refactoring. And these queries can be accessible to any method in the class and thus encourage cleaner design without long complex methods. Okay, so here we are, replace temp with query on total amount and frequent rental points. So let's do this refactoring here. Okay, so let's replace total amount. So we got total amount here. So what we have to do is actually we have to create, it's not exactly just cutting and pasting. Why? Because we have to create another loop. So func get total charge double. Okay. And the problem is we have to do is this. We have to do this for rental and rentals, create a loop. And then what we do is that we have to say var result. Okay, and result plus equals to rental dot get charge, which is actually this part here. Okay, and we return result. Okay, and now that we've done that, we can remove this one, okay, and this one, okay, and replace this with get total charge. And we gotta do a test. Test succeeded, so it works. So we can get rid of this variable here. Okay, so now we're going to do a commit. Okay, so use replace temp with query to move total amount, okay, to get total charge method. Okay, so that's it. So we got to do the same thing for frequent renter points. So same thing, func get total frequent renter points, and it returns an int. So we can come here and okay, so we can do this var result equals to 0, and for rental in rentals. Okay, and we got just type result plus equals to rental dot get frequent renter points rental and return result. Okay, and should compile. Oops, It's a compilation error. And we're going to get rid of this variable here. Get rid of this. And we can see our compilation error says that this can be replaced with getTotalFrequentRenterPoints. Okay, and we got to just do a test again. Test succeeded. Alright, so it works. So I can get rid of this variable here. And we can get rid of this variable. So now notice that our function is really small now. And we're gonna commit. Use replace temp with query to replace total. Okay, we can just look at our code here. Replace frequent renter points with get total frequent renter points, and we just commit, and then we're done. Okay, so that's step 6. So now there's a question, maybe there's a performance. Okay, why? Because we are doing 3 loops instead of just 1 loop, but until I profile, cannot tell how much time is needed for the loop to calculate, or whether the loop is called often enough for it to affect the overall performance of the system. Don't worry about this, okay? Now the thing is, we have a benefit. We have 2 new functions, okay? Here one is get total frequent renter points and get total charge. So we can actually now reuse these functions from the customer class if we just want, for example, just want to query how much are the total charges or the total frequent renter points. It's only until we refactor then we can consider whether we need to optimize or not. And looking at and even though it's 3 loops, the big O complexity is still big O n. Yes, we had only 1 O n just now, but big O n, even though it's 3n in big O notation, it's still considered big O n. Okay, so now that we've refactored our function, we are now ready to add in a HTML statement as the queries get total charge and get frequent renter points are available to any method. Now by extracting our calculations, it allows us to reuse the code. Okay, and if our calculations change, we only have to change the code in one place. Okay, so let's see. So instead of copying pasting, now look at our HTML, our statement line here. So we can actually just copy this, but notice, okay, so let's say I want to do this, and then I just paste it here, and I call it HTML statement. So all I have to do now is very simple. So I can just say rentals. I can just put my H1 thing here, rentals for, okay, and I can just say emphasis. Okay, and I can actually say get title. Okay, so I can just put here, for example, I can just put here the line number of a paragraph, for example. Okay, this result plus equals to P, and I can put here result plus equals to /P for our HTML, and at the end of everything here I can just put the BR here at the end of every line. Okay, and here amount owed is, I could put it here, I could just put some variables, some formatting here. Okay, make sure. Now, of course, what we should do is, of course, add in some unit tests to make sure the HTML statement actually works. Okay, so we can actually put in the HTML statement test here and make sure it works. But as you can see, because we had refactored our both our get total charge, get total frequent renter points into a different function, our code looks so much simpler and easier to understand and to debug. It calls this method. So if there are any changes to the charging mechanisms or to the calculation of frequent renter points, we just have to go to modify either this function or the rental function or the rental get charge or get frequent renter points. So let's just commit this one, and we can see that these are only changes that we have made. Okay, add in HTML statement, okay, method. Okay. Okay, so now we have to go back to our code here. Now the change that we want is now that we want to add in new categories. Okay, so right now we only have regular, new release, and children's. And what we want to do actually is to be able to add in new categories. So what we want to do is that we want to use object-oriented features, which is namely polymorphism. Now, if we don't do that, we got to do a lot of things like switching. And if we look at our switch statement, we are actually switching based on the movie's price code. And it is actually a bad idea to do a switch based on an attribute of another object. I mean, why do I make decision based on what another person does? Essentially, that's what it means. So if you must use a switch statement, it should be on your own data and not anyone else. Okay, so and the reason also because type information tends to be more volatile. So if you want to add changes, it should at least be preferable to calculate it within the class that has the change. So it should be on your own data and not someone else's. So let's go back here. Okay, so and let's do replace it with polymorphism. Okay, so let's come here. So it's based on movie. So let's create another method here called, okay, we got just come here and we got copy. And we could just paste it here. Okay, so obviously this is actually part of movie. Okay, and the problem is now we got days rented. Now days rented comes from here, so this could be provided as a variable. So int. Okay, compiles. Okay, automatic compiles. So what we can do is now replace this. Okay, returned movie dot get charge days rented, and let's test again one more time. And the test succeed. So it works. So now we can just replace this. And okay, we just commit. Okay, you can see our changes. So we move it all the way to rental. Okay. And we say move method get charge from rental to movie. Now, in just reference to our previous refactoring, where there is some duplication here, where we've got rental record and amount owed. So what if the words change? Well, there's another refactoring for that, which is actually using the form template method, which we won't go into. So this can be further refactored into another statement where you can just provide the variables or the values, and you just use a template to replace those variables with another output template. Okay, so now we've got our rental and movie, so we've moved that over there. And since we've moved our get charged from rental to movie, we gotta do the same for our get frequent renter points. So we gotta come here, and we're gonna paste, edit and paste. Okay, so obviously this is based on price code. If price code equals new release and rental, there's no such renting. Okay, days rented. Oh, okay. This rental is actually wrong. Actually, it's supposed to be, there shouldn't be a rental method here. Okay, so actually there's an error here. So over here shouldn't be here. Okay, because this belongs to rental, and this function should actually be a blank. Okay, hold on. Rental class. So actually there was a mistake earlier. Okay, but no worries. So we got this here, and you got this one here. Okay, and over this one should be days rented. This one should be days rented int. Okay, and it works. So let's just comment this out, and we got just return rental returned movie dot get frequent renter points days rented. Okay, and we got test. Okay, succeeded, so we can just remove this. Test one more time. And it works, so let's commit. Move get frequent renter points from rental to movie. Okay, so we've done that. So now, how do we use inheritance? Okay, we want to create more classes. For example, maybe we want to create a class of movies called classics, like Citizen Kane, for example. We want to give special pricing for classic movies. So one proposal could be using subclasses. Okay, so you got movie, you got regular movie, you got children's movie, new release movie. Now, at first it could be good proposal, but actually no, because a movie can change its price code, but an object cannot change its class. So instead of using inheritance, we're going to use the state pattern on the movie. So I'm going to demonstrate for you how the state pattern works. Okay, so we're going to use inheritance. So we're going to replace conditional logic and price code with polymorphism. Step 1, okay, we're going to replace our type code with the state strategy pattern by self-encapsulating the field. And the reason is that any access to type code goes through the setter and getter and allows our subclass to override how to get information and support more flexibility, like lazy initialization, for example. Okay, so this is what we got here. Okay, so this is our movie here, and you can see that this is our price code. Okay, so we got our price code here. So we got price code. So what we can do is that we can change this into a var. Okay, and price code. Okay, and we can use setters and getters. Now in Java, we have get, we replace them with methods, but in new languages we can just use get and set. Okay, get and set. Okay, so we're gonna create a private variable, private var, price code, price, oops, skip, hold on, price code. Okay, and we got get return price code. Okay, and one we can set, and we can say price code equals to a new value. Okay, so these are setter and getter. So we can't do this, okay, because it says the user self, we can't do this. Okay, so we can say price code set price code. Okay, so let's say self dot price code equals to price code. B cannot do this. Okay, we can say that can we do this? Okay, and let's test our code again. And it succeeds. Okay, so we got our price code now. So we replace this, and so let's just do our commit. Okay, so these are changes that we made. Replace okay, so here we go. It's self-encapsulate field. Okay, so let's use self-encapsulate field on price code in movie. Okay, so next we gotta use our design pattern. Okay, we gotta use the design pattern of the state or strategy pattern. So what we do is we gotta use inheritance. Okay, so the next thing is we got replace type. Okay, so the thing is the calculation of charge is based on the price code and not the movie, so we got to replace that, okay, by using a move the method, okay, to get charge. Okay, so we're gonna do this. So let's come here. So notice there's a movie here, so we got put the get charge from here, okay, by calling a method. Okay, okay, so we're gonna do this, return price code. Okay. So by doing this, okay, so what you can do is that using feature Swift, we can get the price code here. Get price func. Get price code. Okay, and we're gonna do this. Okay, and we're going to create a new class. default case of price code dot regular. Okay, so by default we're gonna give a regular class. Okay, and what is the programming error here? Ah, forgot override. Okay, and okay, func, and this one will be switch self case regular return regular price. Okay, case dot children's return children's price, and then case dot new release return new release price. Okay, so there's quite a bit thing of coding here, and then what we can do now is that we can have a private variable called price, which is of type price. Okay, and instead of basing price code based on new value, okay, we can just say that price is equals to new value dot get price, and instead of returning price code, we got to say price dot get price code. And test succeed. So we replace the price code with price classes. Okay, so we can do this. Okay, and just test one more time. Okay, we're done. So let's just put this here. Commit. So you can see this is our code here. Use replace type code with state strategy. Okay. Commit. Okay, so next is we gotta move our move method from getCharge. So notice that our getCharge is over here. Now we got a switch here, right? So what we're going to do is we're going to switch based on the charge. So we're going to create a function called getCharge func get charge. Okay, and we just got return double. Okay, and it's based on days rented. And we just gonna return the regular. Actually, since this by default is regular, we actually can just leave this as blank, because then we're not really overriding it. So we can just return the regular price here. So what's the regular price? Regular price is days rented. Okay, so we got to do this. Result equals to, okay, so the result plus equals to 202. If days rented more, the result equals to okay, equals to 2, and then double minus, okay, 2.0. okay, var result. Okay, and then we got return result. Okay, so let's test one more time. Okay, so test succeeded. Okay, but we haven't implemented our code here. So over here, okay, based on our every leg here, so we got get charge. So what we gotta do here is that we gonna comment this part out. Okay, and we gotta do this return price dot get charge. Oh, days rented. Why is it not integer? Days rented. Okay. Oops. Oh, days rented. Test succeeded. So we've actually managed to move one by one our days charged over here. So we can move this one out. Okay. So let's do the same with this one. Okay. So let's say we comment this out. Okay. Obviously this is going to fail, obviously. Okay, because we haven't put our code there. So we got to copy the code into new release. Got paste this over here. Got return. Okay, and let's test. Test succeeded. Okay. And we gotta do the same thing for this part here. Return price dot get charge days rented. Okay, and this will fail because we haven't put our code into the code there. It'll probably fail, right? So we got to put this logic into the children's class. Okay, I'll paste this here. Okay, and we got to say result is 1.5. So var result equals to 1.5. And we got add, and then we just gotta say we gotta return the result. Okay, and let's just test one more time. Test succeeded. Now, because all of this is is using switch, and we're just using this, so we don't have to, and it's all repeated now, so we can actually just do this. Okay, so now we can just do this, and we just say return price dot get charge days rented. Let me just test one more time. And test succeeded. So all this code now can be deleted. Okay. Right. So this is how we can do it. And then now we can just commit our source code commit. Okay, so replace move get charge from movie to price class and subclasses. Okay, so we can see our changes here. Oops. So obviously our history shows a list of all changes. Okay, so all changes are here. So that's the beauty of source code control. You can always see what are the changes that you made in your class. So if you want to make any revert any changes, you can always just check the source code control mechanism to see whatever changes you made. Always commit often. Okay. So by moving get charge into the price, we can also do the same thing for frequent renter points. So you can look at our frequent renter points. So if it's a new release, if it's a new release and rented for more than 1 day, we give a bonus of 2 points. Okay, so notice we can just come here, price func get frequent renter points days rented int. Okay, and by default we always give 1 point, but if it's a new release and the days rented are more than 1, we can just override the new release. Get frequent renter points if days rented more than 1, turn 2, else return 1. Okay, so now we can actually do this. Okay, make sure, okay, let's comment our code out. Return price dot get frequent renter points days rented. Okay, and we're gonna just run our unit tests again. And test succeeded. So we can delete this one. Okay. And then we can commit. So the same thing is what we did was that we get frequent renter points, and that's what we do. So we just say move get frequent renter points from movie to price class and subclasses. Okay, so that's what we did. So you may complain that this is quite a lot of work, right? I mean, wow, it's a lot of code here, right? But what you get for all this work is this, okay? So it is that your classes are more organized and it's very easy to add in more classes. So for example, now that we've got our default class price and we've got children's price, new release price, and regular price, which actually subclasses from this, I could actually just, for example, I could just create a new class. For example, I could just say class regular grass classic price, and I could just say that for this, if you I could give you more frequent renter points if you return 3, for example. And it's very clear that classic price is based on this. That's it. And I could just add one more case here, and I can just say case dot classic and then return classic price, and that's it. These are all the changes I need. That's all I need to do. Okay, so over here, okay, plus one more here, case classic. That's it. So the changes are only needed here, right? So based on this, I can just test out my classes, for example. Now, also by doing this, I can also organize my code. For example, I could just come here and just say new file. For example, I can just create a new file just for classes on class based on pricing. Okay. So for example, here I can just come here and just say pricing classes, and I can create pricing classes, and I can actually just copy all these classes here, and I can just cut it, and I can just paste it here. Okay, and there are no dependencies whatsoever. Undeclared price in main.swift. Why is it not in my project? Okay, build one more time. Because there's one problem because I have not put it to my unit tests, I believe. Yep, that's that. You can see there. So you can see I can reorganize my classes into a very well organized class. I can create my classic category. If I don't like it, and just delete these classes all in one file without editing another class, another file. I can test one more time. So it's all organized. Yeah. So pricing goes into another. I can still keep my movie, my rental, and my customer inside this class here. So that is the end of assignment 2. So this, we hope that you get to understand how to use refactoring and how it makes your code much more manageable and easier to use. We use a few methods, refactorings like extract method, move method, and replace a conditional with polymorphism. And I hope you learned how to use design patterns and how you apply polymorphism and object-oriented code to create much more easily maintainable code and much more simple to understand. So there we have it. We've done the replace type codes with state strategy and replace conditional with polymorphism. And the reason why we want to use polymorphism is because it allows you to add a new type without finding and modifying all conditionals. And we only need to subclass and provide appropriate methods, and it reduces dependencies and it's easier to update. So here we have the final UML class of the finished refactoring, where instead of just 3 classes of movie, and with only and with just a statement, we created an HTML statement. We created the total charge and total frequent renter points properties, or you can yeah, it could be properties, or it could be methods. And then we got rental, we get extra methods here, and movie, we got get charge and get frequent renter points. And inside of it, it depends on the price class, which has different subclasses where we can change the price using the state strategy pattern. So we go back to our code. So we've done all this, we moved into a new class, and we can, of course, what we can do is we can commit, okay, the final code. And here we go, and we just say finish moving, move. Okay, so over here we put it on to move pricing. Pricing file. Okay. Okay. As you can see in my class diagram, this get frequent renter points. Okay, because this example is based on Java, so it shouldn't be a method. Okay, because actually this could actually be converted into a getter and setter property. So instead of get var, get total frequent renter points, you can actually replace this as, let's say we can just replace this as var. Okay, and then we call this as total frequent renter points. Okay, and we can just say get, and we can just say here. Okay, there'll be a problem here, but we'll just come here, total frequent renter points. Okay, so it becomes a property. Okay, we can test. So we can't. So total frequent renter points over here. Test one more time. Test succeeded. So we do the same thing, since it's only a get, so we don't need to use a method, because methods are actually a Java way of doing getters and setters. So we got to do this, and we just going to say this is a get method, get, and get control I. Okay, total there should be some compilation errors coming up. Okay, if I do this, okay, I'll get my compilation errors. Total charge will be here, and of course total charge is here, and we do a test to convert this into getters, and test succeeded. Alright, same thing for get charge and get frequent renter points. It shouldn't be a function, where we can always revert this into a, since it's a property, so we can always just change this into a property var, and it's a double, and we just do a get. Control I, var integer, and okay, there'll be errors because we converted in from functions. So this one should be rental charge and rental frequent renter points. So rental frequent renter points, rental charge. Okay, rental charge. Let's test. Oops. So this is a bit more in line with properties that we can do. And thank you very much.